This is going to prove if you are strong in organic chemistry. What is the relationship between the compounds labeled A and B? This is compound A and this is compound B. What is the relationship? If you look at these two compounds critically, you will see that they are the same thing. Two carbon atoms, ethene, two chlorine atoms attached to the first and second carbon atoms, meaning that this is 1,2-dichloroethene, right? Same thing here. Two carbon atoms with double bond, ethene. Two chlorine atoms attached to the first and second carbon atoms. And the name is 1,2-dichloroethene. So why would they write the same compound and ask you the relationship between the two? Now watch closely. In organic chemistry, once you picture a double bond between two carbon atoms, what it is telling you is that there is no rotation. There is no free rotation of the two carbon atoms. Double bond locks up two carbon atoms against rotation. If you have two carbon atoms bonded by a single bond and they are carrying chlorine atoms, right? What this implies is that these two carbon atoms can rotate like this. This one can rotate and we have something like this, meaning that this chlorine will come down. And it can also rotate again and the chlorine will come up. But immediately, this single bond becomes double. One of the hydrogen atoms from each carbon will disappear. The same thing here. This now means that the rotation will automatically cease. Rotation will automatically cease. If rotation automatically ceases, it means that this particular compound can never change to this one. It is a different compound on its own. The same thing with this one. Of course, what on earth will make this compound to become this when there is no free rotation? And that is why, despite the fact that there are the same number of atoms and the same bond connectivity, yet these two compounds are two different things because there is no ease in rotation of carbon atoms. So as this compound is, and this chlorine is up here, this one is down here, nothing will make this chlorine to come down again. And here, look at this chlorine is down and this one is down. Nothing will make one to go up and one to remain down. And that is why these two compounds are different. And what is the relationship between them? One, they are similar by the virtue of number of atoms and bond connectivity. Two, they are different because of restriction in movement as a result of presence of double bond. Now, because they are similar and also different, then there must be a relationship. There must be a sacrament between the two. And this is that relationship. Just draw a rectangle here and try to trace the two chlorine atoms. You will make a straight line. Now, if this is a rectangle and this is a straight line, this straight line that runs from one edge to the opposite edge is called transversal. Do you remember your elementary mathematics? Now, draw another rectangle here. And try to trace the two chlorine atoms. Look at it from here to here. You have drawn something that resembles C in this case. So now, because of this, chemists now call the relationship Cis-Trans isomerism. Because these two things are isomers. Iso because they have the same molecular formula, the same structural formula, but different spatial arrangement of atoms, especially chlorine atoms. So chemists now named this kind of isomerism Cis-Trans isomerism or geometric isomerism. Therefore, the relationship between these two compounds of 1,2-dichloroethene is that they are cis-trans isomers of 1,2-dichloroethene. You get it now? If you don't get it, ask question at the comment section.